For more interesting videos, subscribe to Tech Simplified TV and hit the bell icon for updates.
Hey guys, welcome to the 7th episode of PERL programming in VLSI. In this episode, we will be discussing all the file operations. And why the file operations is very important in VLSI is that when you are creating automation, you have to run a tool, and that tool will create some output, and you have to read that output file, check whether that file is existing at the disk, check that file has zero size or not. So these are the basic things. And an advanced side is that when you are writing a script, automation script in PERL for VLSI automation, you have to also dump an entire log like any of the EDA vendor tools which are run a command line tool, and it gives output a log file, okay, whether it is a plain log or it's an error log. Such kind of log you have to generate. So watch the episode till the end to cover all these topics, okay. So without any further delay, let's begin. In this episode, we will be discussing the basic file input output in PERL, shorthand file command, reading from a file two different ways, reading a file into an array, which is different from just what I have told. The next one is writing into a file, dealing with all the standard input output handles, overall log files for a PERL script, globbing and Unix style file operation through PERL, okay. So these are the topics that I am going to cover, and as I have briefed just before starting this episode, that is the goal of this episode, and this is a very important episode, so watch carefully till the end, okay. File IO in PERL, okay. So as you know, like in C language, you have some way of dealing with opening a file, writing something into disk rather than on your screen. So these you have come across only when you learned the C language. I assume you know the C language. Or any other basic language that you have learned, okay. So in PERL, the file input output is very similar like that, but the syntaxes are different. Let's see how it is doing. A file handle is the name for an input output connection between your PERL process and the input output device. So what is an input output device? Monitor is an input output device where we see different outputs coming into our screen. Another is our hard disk, okay, where we are writing our files physically. So these are input output device, and input device is the keyboard and the mouse. So both the standard outputs will go to the monitor, okay, while the standard input will come from the keyboard and the mouse. So these are all standard input output. File handles are all uppercase to avoid all possible collisions with present or reserved future keywords. So whatever file handle we are going to use throughout the PERL are written in all caps. This is a convention, we have to follow it strictly. A file can be opened using the command open, then within the arguments what will be there, the first will be the file handle which is in uppercase, then the mode of operation, so whether we are writing a file or we are reading a file or appending like that, and then find the next one is the file name in the physical disk, okay. It could be a full path of the file name also, okay. Next, a file can be closed using the close command as close, then within the argument only the argument will be file handle, so that will be sufficient. It's a good practice to always use a close to close the file handle, okay, so that you know that whatever memory or processes that you have involved regarding this file writing has been cleared once you exit the PERL script. Open returns non-zero on success, the undefined value otherwise, okay. So this is just the return value of this open command. If the open involve a pipe, we'll see later what is a pipe involved, then the return value happens to be the process ID of the sub process, okay. So these are return value, okay, this you can check. okay, when you are running automation. So that's why I touch based here. When opening fails, it's never a good idea to continue. So you are trying to read a file and you got a jolt and you cannot open the file, you cannot proceed in automation. So you have to stop because there is some issue, right? Similarly, if you try to write and you cannot write, then it is not good to proceed, because if you proceed, all the processes and the LSF, all those will be blocked, and resources will be blocked, and still your outcome is null because you cannot write anything. Okay. So we will see how we can use the different file test conditions also, apart from the regular things that in PERL to tackle with such situation, to deal with such all these scenarios. Okay. Hence, we use die to terminate the program if the open fails. So this is a very useful function in PERL, that if you fail to open a file, whether you are reading, writing, or whatever you are doing with the file, so we die will terminate the program if this operation, open operation, fails in any mode of opening. So we are done with the summary. Now let's go in details. Mode, here in this table I am describing that what are the mode strings. So you remember that I have shared 3 arguments in the open command, open function. So there is one particular where argument is opening a file in a particular mode. So here we are describing that. So the left arrow means we are reading a file, right arrow means that we are writing into a file, double right arrow means that we are appending to a file, and then pipe then dash means we are outputting a pipe, and then dash then pipe is inputting a pipe. And the final one is that plus then left arrow or plus then right arrow means we are both reading and writing a file. So these are the exhaustive list of file operation modes. Okay. So let's go to the next section. Shorthand open command. Okay. So let's see how we use the open. So generally we write open and then in I am writing because we are reading a input file here, and that's why I'm using the convention in, then file name, read from existing file. The same thing we can write in a way, open in then left arrow, as we have shown this operator, right? This is a shorthand, so we are clubbing the 2 arguments. Okay. We can write this with a comma separated 3 arguments also, that is not an issue, but this is a shorthand people use, so that's why I'm showing it here. Then we write open out, then right mode, that is right arrow, and then the file name. This file name could be not only the file name, and it could be that it's a full absolute path of the file in the disk. Okay. So here I have just shown that in when we are opening input file, and out when we are writing a file. So these you can take as a convention to remember or to debug your code, or say you are opening multiple file input file, so you can use handle in1, in2, in3, and if you are outputting multiple files, so you can use handles out1, out2, out3, etc. So this way you can, by looking into the code manually, you can understand, okay, which are the kind of operation, whether it is input operation or it is output operation you are doing. So better you follow some such convention. If you have your own convention, you can use it, but otherwise you can follow this convention. The next one is that out double right arrow file name. This means that we are appending to an existing file. This is output pipe. This is how we write pipe, then the output pipe command. Okay. Or input pipe, in then input pipe command here, then pipe. Okay. So these are all the shorthand open commands that we use. Okay. So we are done with this slide. Let's move on to the next one. Reading a file, reading from a file. Okay. So how you do that? Let's see one example here. Reading from a file handle is accomplished by placing the file handle inside angle brackets. The line input operator are often called as the angle operator. Right? How we write it? First we declare my $input, we declare the variable here, and then we write open input as a file handle, Then here we are not using the shorthand, here we are going explicit. So then comma, then open mode of operation, that is left arrow, and then input.txt. Carefully look that both are in the double quote. So you have to maintain this. Or is an operator, or is a logical or, conditional or, and then die. And we write in the message of the die is that cannot open the input.txt. In case you are opening from an explicit path, then you can mention in the explicit path also. And $bank will return the status, okay, return status. So now we have done the first thing. Next, once the file is opened, in the handle is ready, what we will do? We can process every line. How? We write while, then my $line is equal to angle bracket, then the file handle input, okay, and then we start the while body. And here we do whatever we want to do with the line. So that we want to split the line, we want to print the line, we want to dump it into another file, whatever we want, or we want to print into the monitor, okay, whatever we want to do. Next we close the block and we close the file handle, close input. So you can see here when we are using the close, we are not using the first bracket or the parenthesis here. This is another kind of shorthand. But in the first case, when we are using open, there are multiple arguments, so we cannot do that in the similar way. So this is a just an example, explicit example how you can open a file in the input mode or the read mode. Okay, so let's move on to the next slide. As I have mentioned in the beginning of this episode that the file test conditions is very, very important. We can use die, but at least if we have used all the file test condition, all these condition explicitly described in episode 2. Okay, so you can check out the episode 2 from the playlist, and all these file test condition you can judiciously apply in your case. So I have, that's why touch based this if conditions file test operator. So these are very important when you are dealing with actual file IO in Perl. Okay, these are important here. So I touch based is again, for details you can go and see the description in episode 2. Okay, let's move on to the next slide. Reading from a file. Here we just covered one example, and in this example we'll show another way how we can write the same thing, but there will be some shortcuts we will be using in this particular example. Not using any $line variable, so that is our goal. As usual, we start my $input and we use the 3 argument open, and or we cannot open die, cannot open the input file. Okay, and then we open our while. Now you can see that while, and we in the angular bracket we write input, and then we have the body. Here we can get the line in the $_, which is a default variable. So these default variables I have covered in episode 1. If you have not watched, please go and watch episode 1. And here practically we are using this special variable $_, and this actually lessens the number of variables, and it actually makes the script faster. Okay, so here we are, this is how, and if we want to process further we can operate on $_ in any way. Okay, and we close the while block, and then we can close the input file handle, so the file is closed. So this is another less memory expensive file IO operation. Okay, so we are done with this slide. Let's move on. Reading a file into an array. So this is a very interesting thing. In data structure we have discussed the array. So each file, the concept is here that each file is a collection of lines. Okay, so how we can put them as an array element? Let's see how. So as usual we declare the infile variable and open the file handle here, $file name. So this is another way. $file name is a variable which contains the file name along with its path. So this is another way of opening file. Okay, so next, my $line is in file. We have stored the input file handle into $line, get the first line, and we write the at my at the rate rest. Okay, so in file is equal to get the rest of the file here. Okay, this is the way we can store a entire file into an array, and then we close the in file. So this is the operation how you can get the file into an array. So you're done with this example. Let's move on. Writing to a file. So we write my $out as the convention we are using out when we are outputting a file. Okay, so open out, then the 3 argument operation, that is the right hand arrow is the middle. Okay, so this is the right operation, output.txt, or die cannot open the output file. Okay, for each my $I 1 ... So this for each loop I have already described earlier. So this will start counting numbers from 1 up to 100 as an integer, and with 1 at a time increment. Okay, plus 1 increment at a time. So we print out this line gets $I. Okay, so output file will get all these line numbers, and then at the end we place a \n operator so that the next output will go to the next line. So close here. So all the output from this for each loop will be saved on the output file. Okay, and we close our file handle. This is a way simple, very simple to write a file in Perl. Opening the standard IO. So this is another important section, right? Why I am saying, because when we are dealing with a overall log of a file, right, of a Perl script, when we are doing the automation in VLSI, that time we have to be careful that we judiciously use the correct the standard input output handle. So let's see how. Here let's begin. Standard handles like STDIN, which comes from the keyboard, right? STDOUT or STDERR, these are the output display messages that goes to the monitor, right, are opened by default. So these are predefined, so you don't have to define them. These 3 file handles are very predefined in Perl. Okay, so we can write print stdout enter a number. So this will go to the monitor and print. It is same as print enter a name, but explicitly we can use stdout as a file handle. My $number, then within angular bracket we write STDIN, and once this line is executed in Perl, right, the prompt will wait for you to enter something from the keyboard. Print stdout, the number is that. So here it again goes back to the monitor and prints. So next, print STDERR, that is STDERR, the error has occurred. So this is for error and warnings. Okay, so this is the way we can output the number. Now when we try to create a overall log file, right, I'll be showing later how these all handles can be efficiently used, especially the stdout and the stderr. So we are done with this introduction here about the all stdio which are by default in Perl. Next move, creating overall log file. This is a very important goal, right? When you are writing an automation script in Perl, you have done everything. The code contains everything that you need to do the automation. But one thing we lag is that we don't have a log file, and once there is a long execution happens, all the data that is displayed in the monitor, right, is gone from your hand. So you do not know what happened. So if you give a debug print command, it is also gone. And more difficult factor, if you are launching your Perl script in a LSF, right, it's difficult for you to capture whatever is output. So how to deal with this situation? This is a very bugging thing when you are doing the VLSI automation. How? Let's see. It is necessary to create an overall log file when you run a automation script in VLSI that can capture the screen dump of messages. Where these messages might come from the VLSI tools that you are running command line through Perl, or you are doing some Perl calculation and outputting something, anything, or something error has come out from the Perl script. So all these we need in a single log file or more than one log file. Okay, let's see how we can do that. So we want to capture all the errors and warnings. use file : t qwt. So this file : t module is very important module. So if it is not by default with you, you can request your Unix administrator to install it from the cpan modules. This is the beauty of the PERL. So cpan contains hundreds and thousands of predefined PERL modules which you can readily use. So you don't have to invent the fire. So it is there, you can just use the fire to cook your food. So this is the very important. So it does a T, so that means it's T like the Unix. So it also prints in your monitor and also dumps in the log file. Then T open stdout, and then the operation is write operation, that's why here, and then my perl script dot log. So it will contain all the normal messages, okay. And next we write T STDERR, okay, then write, and then my perl script dot error dot warning dot log. So these two log file will capture the regular messages, the first one, and the second one will capture all the errors and warnings. So these errors and warnings can be from the VLSI tool that you are using also. So this is a very important thing that I have initiated in the beginning of this particular episode, right? So you don't need to close them, they will be automatically closed. So once your PERL script execution finishes, all these log files will be there, okay. So you can check in open these log files in your text viewer, and you can interpret what has gone wrong or what has gone right. So this is the very important thing. Globbing, the next topic we are discussing here. What is globbing? Okay. Definition is the expansion of a file name argument patterns into a list of matching file names. So this is another kind of file operations, right? It's not the direct read or write, but we are dealing with files in a different way. How we do that in Perl? So my @files, then we provide the directory path inside the angular bracket, and then star.c. So wildcard searching, all the C files will be now go in the array files, okay, and then we can operate on each and open or close whatever we want to do, okay. Another way do the same thing is that use the glob operator. So that is why we are saying globbing. So glob, then the entire path which goes in the double quote here, and then the wildcard. So home/docs, then star.c, all the C files will be saved inside the array, and then we can operate on each file. Say, just for an example, you are running a check on all the verilog files that is inside your in a particular directory, design directory, and maybe you want to source them to some particular tool which will be they will be as an input. So you can use this method to get all the verilog files, including the top.v as well as the small blocks.v. all those will be captured. So you can then use the PERL to feed them into the actual tool, okay. So this is why the globbing is very much important, okay, in file operations. So this is a different kind of file operation, but I am covering inside the episode because this is very much important in VLSI. Now while my $file then abc star.html. So this is another way of globbing, okay. Output each .html file starting with abc. What we do, we print here, okay. We can print like this, okay. This is one way, okay. So this is another kind of globbing, but here we are using the while. So this is not we are opening a file, that we are listing a list of file and printing them like that, okay. And similarly here we can do the same thing with the for each loop, okay. And here $file, each $file will contain each file, and we can print the names, okay. Here name of the file, okay. So here this is how we can do the globbing by different methods, okay. So this is how we get all the .v files inside a directory or .c files in a directory, and iterate over them, and then for each file, whether we want to open them or not open them, or do some kind of sed or awk operation on them, that is up to you. So that you can do. So but this is the starting method, how to do how to deal with such situation when we have to do multiple things in Perl. So deal with multiple similar type of files in Perl. Okay, so that's why globbing is important. So we are done enough talking on this slide. Let's move on. Unix style file operation in Perl. So this is another way of file operation. I'm not talking about input output, but how we do. Let's see. So some commands are there in input that we in Unix we use for manipulation, file manipulation. But the same thing we can do inside the Perl. How? Let's see. Unlink myfile.dat. This will remove the myfile.dat. Okay. Unlink star.o. Okay. Then it will remove the star.o in Unix. So sometimes maybe we are compiling a C code and the object file comes, and the next run of the Perl script we may have to clean all the .o files there. Okay. So that time we may have to do that. Or you can use a unlink command at the beginning of your script. So you are using a static name of your log file. So if any previous log file is present, you want to delete it. So you can use this unlink command along with that log operation, log file operation I have just shown few slides back. So this is a one good thing of unlink. Rename old name and the new name. So maybe you want to rename your log file to the log.old, okay, or some other nomenclature you can use. So that time you can use rename. So I'm just giving a specific example, but it is not limited to that. But what is important in VLSI, I'm just emphasizing here. mkdir, then data files, then 077. So this is how you can create a directory and give a permission to it, okay, while you are creating. So this might be important because you might have to create a directory where all the outputs of a particular tool run will go. Okay, so you are running a tool which will create several files and they must go in a particular directory. So that time you can use the mkdir. RMDIR is the another thing that in any previously created directory you want to remove, which is not important for this particular run of your Perl script. So you can use RMDIR. And chmod, then the permission number, right, and then the program file. So it can give a permission. So you want so you say you are creating some kind of executable files and you want to change their permission to executable and run them. So you can use, okay. So this all things will help you for the file operation. So whether directly opening a file or dealing with a file, all these things in the automation in Perl. So I think we are done with these slides. Let's move on. I'd like to thank you guys for listening up to this point, and please do like the video if you have liked the content of this video or the series, and please subscribe if you have not don't yet. Okay, you have not subscribed, then please subscribe and share with others so that others get the same help as you are getting right now. Okay, thanks for watching. Bye.